Hello, AP Chemistry, and welcome to Hess's Law, finding delta H the easy way. Technically, this is easy, right? Because one, we don't have to run an experiment. But I guess some people won't find it easy. Depends on your comfort level with math and your level of organization, right? Because if you always write these out neatly, it should be easy for you. Okay. So Hess's law really just takes the idea, right, that that enthalpy is a state function, right? Meaning that it doesn't really matter, right? Going back to that mountain example in your textbook, right? If we go from the bottom of a mountain to the top of the mountain, right? We have changed elevation by the same number, and it doesn't matter if some people hike the whole mountain, right? Which obviously is a boatload more work, right? Or if someone drove up the mountain or took a tram to the top of the mountain, right? That doesn't really matter. Everybody changed elevations the same amount, okay? Likewise, heats of reaction are the same way, right? If we want to know the heat of this reaction, we can take some other reactions that we happen to already know the heats for, because experimentally these would have been determined, right? And there are entire handbooks of chemical information that are just filled with things like this, right? What are the heats for given reactions, okay? So anyway, if we want to know the heat of this reaction, and we have access to this information, all we have to do is rearrange these so that way it matches this, because again, it doesn't matter how much work it took to get there, right? All that matters is the difference, right, from beginning to end. So what I like to do is I like to just make sure I get everything on the right side first, right? So if I know that NO has to be a reactant, I need to look through all my options and find NO as a reactant. And so I'm going to use that one, right? If I have NO gas plus O3 gas gives me NO2 gas plus O2 gas. And I left this reaction as written, which means that this is going to stay negative 198 negative 198.9 kilojoules. Okay. Now, I also need O gas as a reactant, which means this one, right? So, I'm going to take my 2O gas, and that's going to give me O2 gas. I flip this reaction, so what happens here? Ding, 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 negative 495. Okay, now I've got my reactants on the right sides, and I know that I need NO2 as a product. That's on the right side. So now it's just a matter of deciding if I have what I need, right? I have NO and I have O. I have NO2. But it turns out that, actually, I think that reaction is not completely written right. Let's check in a minute. We have these over here, right? We also have this over here, and we have to make sure they cancel, right? We have to make sure these cancel. We have to make sure this cancels. So if we look over here, we have an O3, right? So O3 gas, 3 halves O2 gas, and since we flipped this one also, we're going to have to flip this, which means positive 142.3 kilojoules, okay? So if we look, right, we have NO and O and NO2. We have O3s that can cancel, and now we have O2s that can cancel. Now we just have to get the stoichiometric numbers to match. So let's go ahead and do that. So we know that we need one of these. That's right. We have two, but we only need one, which means we're going to take this whole thing and multiply it by 1/2, okay? And if we do that, right, and here is where depends on how you like to organize things, right? That means that instead of 2, this becomes 1. And instead of 1, this becomes 1/2, right? And then this still gets multiplied by 1/2. Yes? So it depends on how you like to organize. Now, if that's the case, then it turns out that if we look around, right, we have 103, 103. Here we have 1 plus 1/2, which equals 3 halves, which means all of those cancel, which means that all I actually have left are the components I was looking for, right? We have NO plus 1O gives us NO2 gas, right? Again, it doesn't matter how much work we put into climbing that mountain, right? It's the change that matters. So then all we're going to do is take our values, right, and add them together, right? And that's how I like to think about it, right? I'm just going to take negative 198.9 plus 1/2 of negative 495 plus positive 142.3, okay? And that's going to give us our final number, which I think you can do on your own, I feel like. Yes? Fantastic. Do some Hess's Law practice. There will be plenty in your web assignment. Don't worry. Have a wonderful day. Be good, and I'll see you soon. Bye.